we are given a probability distribution function, which is given by this piecewise function here. And we're asked for the very first question, prove that this is a probability density function. So I'm going to scroll all the way down past the previous questions. And if we write it out again, let's say f of x. Okay, if that is equal to this piecewise function, then there are two rules that we need to consider. Okay, the first rule is that everything must add up to 100%. Okay, I'll finish writing this off. And 0 elsewhere. Okay, so rule number 1. If you add everything up, the area underneath the curve must be equal to 1. So we've learned integration, and integration is the area under the curve. So if we find this, right, for f of x, the x, that must be equal to 1. So to say that there is 100% probability that there is an area underneath the curve. The second rule is that there can be no negative values. So for f of x, it must always be greater than or equal to 0. Okay, so we have a calculator. This is the calculator assume question. Let us go through and figure out the very first one. So the integral from minus infinity to positive infinity, hang on, how do you even put a piecewise function into your integral? Well, what we can say is, let's plot this first of all, and then I'll explain it a little bit further. So if I go to my graph and table, I'll clear what I've done before, and I say 2.5 minus x, okay, and I can use a given that symbol. We'll see if this works actually. I'm not sure if it will, but well, I'll give it a shot. So given that 1 is greater than or equal to x is greater than or equal to 2, okay, so yeah, I just plotted it here, and then for everywhere else it is going to be 0 elsewhere. So for this one we'll say x is, you don't have to plot it like this, I've just I guess wanting to show you what it looks like on the graph. So the given that symbol, which is what is being shown there, is to say given that like x is less than 1, given that x is greater than or equal to 2. And then I'm just making the colors look nice for you. And so we get this looking function here. Okay, so we can see that it doesn't dip below 0. So that's important. And then this area is what we're trying to figure out. Does that equal to, like the area under the curve, does that equal to 1? So first of all, when we're writing this, we can't really integrate the piecewise function, but we do know that there's a couple of points that we're going to snip it with. So if we've got our function here, we can see that there's these points here that we can cut it. So we draw a little scissors, and we're going to cut this function so that now the integral goes from negative infinity to 1, and it's always 0 because this is this kind of bit over here. And then we say plus 1 to 2 for the actual normal function, right? Which is our 2.5 minus x. And then the last one, I'm just going to put it down over here because I've run out of space, is from 2 to infinity. And again, that's back to 0. So that gets deleted, and what we're left with is just this bit here, okay? And the shortcut is to look at your piecewise function here, and then just grab the bit here, right? Just grab that bit, and these become your bounds, and this becomes your function. So that's the shortcut. So now we've got a calculator. Let's just use the calculator to figure out the rest of it for us, okay? So we'll go back to main. I'll open up my keyboard. We'll go to Math 2 to get our definite integral, and we'll go from 1 to 2, and we'll go 2.5 minus x for x there. And it does equal to 1. So use calc, and you can say 2 2.5 minus by x dx is equal to 1. Okay, and then we can say like graph using calc. And then we can say that if this is our thing here, then this is our function, and we can say uh, f of x is always greater than or equal to 0. And then finally, just let the marker know what our final statement is. And the final statement is it is a PDF as both rules hold. Okay, so now we're going to get to part B, and that is asking us to determine, okay, what is the probability that x is greater than or equal to 1.7? So it's always worthwhile to draw the graph again. And if we draw this guy, then this is 1, this is 2, and this function here is 2.5 minus by x. I'll just redraw that again. Okay, so what is the area under the curve over here? So I guess we all know it's just going to be this little bit in here. So that's when we bring out the calculator and we say that p of x being greater than or equal to 1.7, or in this case greater than, but because it's continuous, it doesn't matter much. So if we draw the integral, so that'll be 1.7, the top one will be infinity, and we'll have f of x back down here. Now, we all know, my handwriting's been a bit shoddy today, and we all know that we can split that up to 2, right? So this is equal to, straight away in your head, you know, it's 1.7 to 2 for 2.5 minus by x. On that, we can say just use calc. And that is equal to our final equation there. So I'm just going to put this one down, or actually I can just edit this one to say 1.7. Now, if I had this in standard by accident, it'll give me something horrible. Let's leave it in decimal to give it something a little bit easier. So this is equal to 0.195. Cool. And that is part B done. Next is we're wanting to find this one, the probability. So this is part C. So the probability that x is greater than 1.7, given that x is already greater than 1.3. Okay, we're going to use this rule here to say that the probability of A given B is equal to the probability of A and B, all divided by the probability of B. So here we're going to have to divide by this thing in pink here. Okay, we're going to have to divide by that. So graphically what that looks like is that we've got this looking curve, and we're saying that the thing in pink is from here onwards, right? So that means that this little bit here is no longer 100%. It's saying that this area is now the 100%. So we need to remove the area that we've already, we need to just say that this area is going to be the 100% now. So we divide by that pink area. All right, and what do we divide the pink area into? Well, we divide it into the little red area, and then that will give us our probability. So what we can say is the probability of x is greater than 1.3 is equal to, let's just skip straight to the integral because we've done this a few times now. And we'll say use calc. And that therefore becomes, we can just, again, quickly grab this guy. That therefore becomes 0.595. Therefore, our final equation, right, our final equation, I'm just going to rewrite this to make it easier for you to understand. But if you do have time in the exam, it could be worthwhile to make it nice and neat. But if you don't have time, you can just skip straight to the calculations. Okay, this is equal to, we now divide by that 0.59. And if you want to get real fancy, you can, yeah, I'll just go straight there, 0.595. And we now grab the previous value of what we used before. So the previous value was 1.7, and that was 0.195. Okay, that we can now grab our calculator, push this down over here, push this value at the top over here. I'll just write it out. And that will give us this answer. You can round to a couple of significant figures. 3 sig fig. And that'll let the marker know what you're doing. Cool, let's go on to part D. Write down an expression that, if evaluated, gives you the expected value. Now you have a formula sheet, and on the formula sheet is the expected value. Now it is a weighted, it's like a weighted average. So hopefully you've seen that before. But in this case, it's going to be the expected value is equal to the integral from negative infinity to positive infinity for x f of x. Okay? And that basically means that, let's say you've got 2 tests that you do in the year. One test is worth 70% of your mark, and another test is worth 30%. That is like saying the x value. Now, if you only score, let's say, 40% on that one, and let's say you score 80% on the next one, that's like, ooh, that is like your f of x value there. Okay, so that's why I consider it a weighted average. But this is directly from your formula sheet, so it yeah, it'll make it like quite easy. But we're gonna have to go one step further here, and that is write it out with actual numbers because we want to have the expression itself. So what we can say is that this is equal to, now again, just from 1 to 2, put an x out the front and put a bracket in there and just say this. That's your final answer there. So hopefully that makes sense on how to do it. So now we want to have the next part of the question here, part E, is asking us to, I'll just scroll all the way to the top so we can find that. So part E is asking us to find a simplified expression for the cumulative probability density function. So find expression for your CDF. Now, again, this is on your formula sheet. What you can say is that it's the area under the curve, but you're going to calculate the area under the curve up to a point of x. So with your graph here, you're going to calculate your point up to here. So as you roll x to infinity, you're going to figure out your cumulative probability density function, or CDF. So you can, if f little lowercase means that it's just the density function, the PDF, what we're going to say is this is now the CDF, so it's going to get a big capital. And this is going to be for an infinity from, we're going to start from negative far on the left-hand side and just move it to x. Okay, and so this will be for f of x. All right, and now what we want to do here is figure out what this is going to be equal to. So there's two sections, I guess, and importantly, it's when it crosses this line here at line 1. Okay, so up until that point, it's always going to be 0, right? So it's always going to be 0 for up until point 1. So, but then afterwards, when we get into the realm of actually hitting this density function here, it's going to have a value that isn't 0. And so I'm just going to scroll over to here to give myself more space. Now, what we can say is that the integral, all right, from 1 to x, given that x is less than 2, all right, so for x being less than or equal to 2 there, it's now just going to be 2.5 minus by x. Okay, so let's figure this out with the calculator. So we're going to say use calc, and let's bring up the calculator. So I'm going to grab my integral, put it from x, put it from negative infinity, and I'm also going to put it from that 2.5 minus by x. It doesn't quite like that one, does it? Dependent value. Okay, so what we're going to do first of all is just integrate this guy normally. So no definite integrals here. So just that 2.5 minus x for x. And that gives us this value. I'm going to put it in standard. And so then what we can do is say for the very first bit, it's going to be, so this would be minus 5x and all divided by 2. For the very first bit here, it's x, and then it's 1. Okay, so we leave the first bit as is, right? Because it gets substituted with x. But then we minus by, we grab all of this, and wherever we see an x, we're just going to put a 1. And we hit enter. And what we can do is grab this guy, and just to make the maths a little bit easier, simplify. Okay, and this has given us a nice simple answer here. So this is now equal to minus 1 minus 4 all divided by 2. Okay, but for areas outside of this, so if we have x is less than 1, our big value here, the cumulative value, will be 0. But then after 2, right, our value here is just always going to be a constant. It's going to be the integral from 1 to 2 for 2.5 minus by x dx, and hopefully you realize that that's going to be equal to just 1. Okay, so let me prove it. We'll go all the way up to the top. I can grab this guy, and this guy here is equal to 1. Okay, so now what we can say is that f of x is a piecewise function, right? It's going to be that piecewise function, and we can say f of x is equal to, do the big curly brackets, and it's going to be 0, okay, for x is less than 1. And it's going to be that, I guess, kind of crazy function that we figured out earlier, that the one that we factorized. So that's going to be minus x minus 1, and then was it x minus 4. Okay, and this is for to 2, and I'll also put a little divide by 2 at the front there. And it's always going to be 1 for x is greater than 2. Okay, that's it. That's part D. But now we've got part F here. And this is saying, using the simplified expression for your cumulative probability density function, what is P of x now that it is greater than or equal to 1.7 there? Okay, so using CDF. Okay, so the problem is that our CDF tells us, right, it scans from left to right, which is why it has that negative infinity to x here, right? That's why it has that. So on our graph, if we draw a line, right, I'll draw a pink line somewhere, it'll only tell us this part. It won't tell us the other part. Okay, but this is being annoying because it says I want it greater than or equal to. So that's the red bit here. So in probability, there is an equation to say, all right, the probability of event A not happening is equal to 1 minus that, all right? So we're going to use the same thing. we're going to say it's 1 minus the CDF. That's the trick. So in our case, the probability, right, of x being greater than or equal to 1.7 is like saying 1 minus the probability of x being less than 1.7. Okay, so now we can say that this is equal to 1 minus the big value of f at 1.7. Okay, and that is like saying 1 minus pi. We've now got our value of, it's minus, um, and from the previous part of the equation there, it's, get it out up on the calculator. It's this 1.7 minus 1, 1.7 minus 4, and then we can use our calc. You probably don't have to write the second line in, you can just probably say use calc. Okay, so I'm going to be a bit cheeky here. I'm going to cheat a little bit and use this given that and say x is equal to 1.7. And I'll make sure that, so that substitutes it in for you, so you don't need to write it a bunch of times. And then we're also going to grab minus 1 minus this value here. And it is equal to 0.195. And there you go. There are plenty of other exam type questions that you can find on my website in the description below. Otherwise, you can leave a comment and I'll get back to you. Would love to help. So like it if it helped you. Otherwise, share it with some friends. But if you want to get good marks, go to the website. There's plenty of exam type questions with solutions, hints, and also videos, all for free.